Hey, what is up everyone? I hope all of you are doing great. And in today's question we have a table of height 1 meter has a hole in the middle of its surface. A thin golden chain necklace of length 1 meter is placed loosely coiled to the hole as shown in the figure. Okay. One end of the chain is pulled a little away through the hole and then released. So one end of the chain is just pulled downwards and then it is released. Friction is negligible and as a result the chain runs smoothly through the hole with increasing speed. So as the chain falls downward, its speed keeps on increasing and eventually it will hit the ground. Now we need to find out three things here. Speed of the chain when it falls by a distance x, so this one would be x. Time taken by the lower end to reach the ground, that means this end to reach the ground starting from the table. Time taken by the top end to reach the ground, right? So top end means the other end to reach the ground. So let us analyze the situation here. At t equals to 0, that means when we are starting our stopwatch, this end will give a slight pull, right? And the gravity does the rest of the work. It keeps on pulling the rest of the chain downwards. At some instant of time, x amount of the chain has fallen downwards below the table, and let the speed of this portion be v, right? Now of course the chain, each point of the chain will have the same amount of velocity because length of the chain is not increasing, right? Now here comes the important part here. On this portion of the chain which has fallen by a distance x from the table, gravity is acting downwards, no doubt in that, and there will be an additional force which will be applied on this portion by the portion of the chain which is at rest, which is over the table, right? Why? Because if you zoom in at this portion, if you see here, this portion which was initially at rest, suddenly it gains a velocity of v. That means there is an increase in momentum, okay, sudden rise in momentum which will result in an impulsive force. We call it f prime, right? So due to that there will be a tension force acting upwards on this hanging portion of the chain, right, which will try to stop this motion, okay, which will act against the gravitational force. Now if we try to find out this tensile force which is acting upwards, we call it f prime. It is nothing but the rate of change of momentum of this portion of the chain, this elementary portion of the chain. Let us take that mass of that elementary portion is dm, which gains a velocity v. Initially it was at rest, so 0, and dm is nothing but lambda, which is mass per unit length, times v dt, because in a small time interval dt, okay, this portion, this length of the chain gains a velocity 0 to v, right? So dm would be lambda times v dt. So the tensile force keeps on changing with speed. So more the portion of the chain hanging below the table, more will be the velocity or more will be the speed, hence more will be the tensile force acting upwards, right? So if you, and that formula would be lambda v square. You can just remember, it is a very standard formula. So if you draw the free body diagram of the hanging portion of the chain, there will be two forces. One is due to gravity, so m times g, where m is lambda times x times g acting downwards, and one would be the tensile force, that is lambda v square acting upwards, right? So net force is this one, which is equals to mass times acceleration. Okay, so expression of acceleration with respect to speed and the length of the chain looks something like this, writing acceleration as v dv dx. Okay, now we can just manipulate a little bit. 1 by 2, if you put here, we can write dv as d of v square. Okay, now substituting v square as a temporary variable z, we can just modify this equation like this, and this equation is a standard differential equation which we can solve using the concept of integral factor, which is e to the power integration p dx, where p is here 2 by x. Okay, So this is a nursery level concept. You can just find out the integrating factor, which is x square. Just multiply x square with the whole equation, and the whole equation will reduce to this one. Okay, ddx of zx square. I won't explain this thing because I know that my viewer are smart enough to analyze this one. So if you keep on integrating, keep on solving, we will get zx square, which is equal to 2g x cube by 3, and finally get z equals 2g x by 3, and we have already taken z equals v square. So just put v square here, you get the expression for speed of the hanging portion. Okay, when the hanging portion is of length x, so it keeps on changing with x, right? So this one is the answer of our first question. So what is our second question? Time taken by lower end to reach the ground, right? Very easy. So v is dx dt, and we can just pull x at this side, x to the power minus half, and we can write v as dx dt. So at t equals to 0, x is 0, that means no portion of the chain is hanging at any time t, or after a time capital T, the whole length of the chain is hanging vertically. Okay, because the length of the chain is also 1 meter, and the length of the table, height of the table is also 1 meter. So the whole chain will be vertical at that time. So 0 to 1, which is this one is the length of the chain, or actually height of the table, which is also equal to length of the chain. Okay, so if you calculate this one, you will get t equals to 0.77 seconds. That means the time taken by the lowest point of the chain to touch the ground would be 0.77 second from the initial starting of the motion. Okay, so we got our second answer. Now let's come to our third one. What was the third one? Time taken by the top to reach the ground, so the other end to reach the ground. Okay, now just when the bottommost end touches the ground, the situation looks something like this. This whole length of the chain is 1 meter. Okay, now some amount of chain falls on the ground, and due to gravity, the other portion, that is the vertical portion of the chain, falls on the ground, right? So at this instant, speed of the whole at any point of the chain is root over 2g L by 3, because we already know the expression of velocity for the hanging part. So just put L equals to 1, you will get this amount of velocity is this one. So of course this whole chain, this end is falling due to gravity, so the acceleration of falling would be g, which is nothing but 10 meter per second square. So the displacement or the distance needed to travel by this topmost end is 1 meter. So s equals to ut plus half at square. So s is 1, initial velocity is 2.58 downwards, acceleration is 10, so we get here 5. So we got a quadratic equation of time. Solving it, we get 0.25 seconds. That means the top end will hit the ground 0.25 second after the lowest end hits the ground. That means from this situation till the whole chain falls on the ground, it will take about 0.25 second. So this is not our answer. Our answer would be, so the top end hits the ground after 0.25 plus the time taken by the lowest end to hit the ground, that is 0.77 second. So adding these two, we get near about 1.02 second. So this will be our answer for the last question. So let me summarize the whole situation here. At t equals to 0, we gave a slight pull, the chain starts to fall. When the whole chain, which is of length 1 meter, and the height of the table is also 1 meter, so the diagram will look something like this. From this situation to this situation, time taken is 0.77 seconds. Okay, and from here to here, when the whole chain falls on the ground, the time spent is 1.04 second. Okay, and from here to here it is 0.25 second. I know this video is slight lengthier than our traditional videos, but I hope I was able to clear all of your doubts, right? And if you like the video, please give a thumbs up, and if you are new to this channel, please do subscribe, share it with your friends, and Thank you. I will see you in the next one. Peace. Take care.